Okay, so we talked about significant figures in a previous video. Now we're going to talk about how do we deal with significant figures in calculations. Let me make a point about this before we get into it that may not make a whole lot of sense to you, but I do want to convince you this is important to a scientist, right? It turns out significant figures are the way to communicate from the measurer to the reviewer how precise the calculation is or how precise the measurement is. So it turns out it's really important. It's difficult to appreciate how important it is when you're in the middle of it because it just looks like a bunch of details. But I said all that to say I'm glad we're doing this section. I think we need to do it on purpose because most of the people taking this class are going to be doing real measurements in real life that really matter. So, all right, significant figures in calculation. So first of all, we need to talk about the rules for rounding off. The key math skill we're dealing with here is the rules for rounding off. The rules for rounding off. And so here are the two rules. If the first digit to be dropped is 4 or less, then it and all the following digits are simply dropped from the number. If it's 5 or greater, then the last digit retained is increased by 1. So we round up. And you've probably seen this before in previous situations. So let's look at this first example. The number to round off. If the number to round off is 8.42, right, 8.4234. If we're supposed to go to 3 sig figs, then that means we've got to go, right, we've got to drop off that. Well, it turns out that was a 3, right? Look at that. You see that? That was a 3. So the first number to be dropped is the 3. Well, 3 is 4 or less, right? And so therefore we simply drop it, and it becomes 8.42. All right, if we take this number to 3 sig figs, then the first number to be dropped is an 8, right? You see that there? And so if it's an 8, that means that the 7 has got to be increased by 1, so this becomes 14.8. You see that? And then finally, let's do this one to 3 sig figs, right? If that's the first number to be dropped is a 6, which is 5 or greater, then this number has to be rounded up, so it becomes 3260. Okay, so again, this is probably something you've seen in previous conversations, but those two rules are important, and we're going to use those. All right, so let's go on down. Write the correct value. Oh, here's a learning check, yeah. Write the correct value when 3.1457 is rounded to each of the following digits, to 3 sig figs, and so in the first instance, it's 3 sig figs, right? There's the first number to be dropped is a 5. So this is going to go to 3.15, right? Because that 4's got to be rounded up. Now, if it's going to go to 2 sig figs, let's do a different color for that, then we're going to be going here, right? And the 4 is the number that's to be dropped. And so that's going to go to 3.1. Do you see that? Okay, so that'll take some practice if you're not used to it. If you are used to it, we probably should simply move on. So the next thing that we want to talk about, and this is a core chemistry skill. The core chemistry skill is using sig figs in calculations. That's really what this whole conversation is about. So in multiplication or division, the final answer is written so that it has the same number of sig figs as the measurement with the fewest sig figs, okay? So for example, if we multiply the following measured numbers, this number, let's go here, has 4 sig figs. This number has 2 sig figs. And so the answer can only be reported to 2 sig figs. Because 2, whoops, where are we here? Because 2 is less than 4, right? And so we're going to go to the less of the 2. 2 is less than 4. So this has to be reported to 2 sig figs, so we report that to 8.6. All right? So that's for multiplication and division. And frankly, I think that's easier than addition and subtraction. Let's do another example of multiplication and division. So I'm going to make little notes to myself every time. This has 3 sig figs. This has 2 sig figs. And this has 3 sig figs, right? So 3 sig figs times 2 sig figs is going to make, our top is going to be 2 sig figs. And then 2 divided by 3, our whole answer is going to be 2 sig figs. So we'll put this in the calculator. 2.15 times 0.3 divided by 1.88 gives this big long number. And we have to round that to 2 sig figs, right? So we go here And it's the 3 that we have to drop, which is less than 4, so we simply say 3.4 centimeters. All right, now adding significant zeros is important to appreciate. If you're using a calculator, if you depend too heavily on a calculator, then you could be in trouble. So 6, for example, 6.0 divided by 2.00, if you just put that in your calculator, it's just going to tell you 3, right? That's what you're going to get out of your calculator. So let's go here and let's say 6.0 is 2 sig figs. 2.00 is 3 sig figs, right? Well, 2 divided by 3, 2 is less than 3, and so the answer is going to have 2 sig figs. Well, if we put it on a calculator, we're just going to get 3, right? So we need to add zeros to make it 2 significant figures. So if we say 3, it's already down here, right? If we say 3, oh, what's going on here? What's going on here? Come on, stop it. If we say 3, we need to convert that to 2 sig figs. It's going to be 3.0. So we add significant zeros if your calculator doesn't show it, right? And we know how many zeros we have to have because the rules. We had 2 sig figs up here. We had 3 sig figs down here. So the answer has to have 2 sig figs. All right? Okay, so let's do another problem, okay? So let's take this one. This is a learning check, so we're just going to do it together. Pause the video and make a guess before I do this publicly. Okay, so you can tell. So let me suppose that you actually did pause it. 5.00 times 3.408 divided by 2, and let me make my sig figs calculation or notes first. This is 3 sig figs, this is 4 sig figs, and this is 2 sig figs. So the least of all those is 2, right? So I'm going to put all this stuff in my calculator, and then I'm going to make sure my answer has only 2 sig figs. Let me grab my calculator real quickly. I meant to have it here with me. It's going to take me just a second. Okay, and it's 5.00 times 3.408 divided by 2.0, and that's going to give me 8.52, 8.52, but I got to write that to 2 sig figs, right? So, that's the first digit to be dropped. It's 4 or less, so I'm going to say that this is reported to 8.5, okay? And that's the answer, 8.5 centimeters cross off, so it's going to be 8.5 centimeters. That's my answer. Let me put my calculator back over there and say that that's it for that question. Okay, so now let's talk about addition and subtraction with measured numbers. Now, addition and subtraction, here's the first thing we're going to do is with addition and subtraction, is we're going to line up the decimal points. Point, 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 point. We've got to line the decimal points up, okay? And then the rule is the final answer is written so that it has the same number of decimal places as the measurement with the fewest decimal places, okay? So that's too thick, isn't it? Let me get rid of that. Let me get rid of that and come over here with green and say you see that's the fewest, right? Okay, so I'm going to put this all in my calculator, add everything up, and when I add it all up, I get 66.102, but because this number here has got only to the 10th place, my answer can only go to the 10th place. And I'm going to do that. When I'm doing this in class, I'm going to do that with a dotted line every time. It just makes it much easier for me. I'm going to first of all line up my decimal places, point, 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 right? Then I'm going to put a dotted line such that the fewest decimal places dictates where the dotted line goes, right? Then I know how my answer is supposed to be. Okay, so the least precise goes to the 10th place, then my answer can only go to the 10th place. Okay, so let's do another example. In another example, we're doing a subtraction problem, and I'm going to do the same thing again here. I'm going to go point, point, and I'm going to subtract these, and when I subtract them, I'm going to put my dotted line to the least precise, which just happens to be, that's my least precise, it only goes to the 10th place, and so therefore, my answer can only go to the 10th place. And I'm going to round up because it's 62.09. All right, is that helpful? So finally, let's do this last one. I'm going to ask you to pause the video, look at it, and do it private. Do it independently, and I'm going to do it also. Okay, so let me suppose that you did pause the video. Okay, and here's what I would have done: 82409 22.0. This is an addition problem, right? And so I'm going to get my dotted line. My dotted line goes there because my tens place was dictated by this number here, right? That was my least precise. So let me come back over here. This is an addition problem, so this is going to go 904,401, right? And so now I know that I can only report this to the tens place. That's the first digit to be dropped, and it's 4 or less. So this is going to be reported as 104.4 milligrams. Okay? All right. Hope that's helpful. And go practice. You're going to get some homework problems for this that'll help you identify how well you know this. All right. Good luck.